After I ended the last video, I was looking at this, and I've done this a few times, but I'm starting to realize, you know what? This switch, even though it's opposite of this switch, it's actually redundant, even though they're polar opposites. And the only thing we really don't know is what keys go to what actions. When we set up a menu choice, the contract between us and the engine is that our actions are bitwise mutually exclusive. They start at 1, and they go upwards just by a left shift of 1 bit. I hope that makes sense to you, what that left shift of 1 bit means. I'll probably explain that a little later in the video if necessary, but that's the contract. We have to have a max. We start at 1, and then we just move on up like that. And so the only thing we really need from the game as an engine side is, hey, which keys are you interested in? So I'm not sure if this is going to work, but I think we can get rid of this because we know the actions are sequential, and then we have a max. So I'm actually going to remove this redundant switch. Sorry I added that in the last video. Let's go here and get rid of this as well, and then in the key mapper we'll get rid of that as well. I'm not sure this is going to work. I hope it works, but I think we can get rid of that redundancy. If you remember back to our graph here, in the last video we implemented this key mapping to actions. That's essentially what I just closed off the window. We need to do this input part. So that's our goal in this video. Control-Alt-L, go to input, add class, even though you can't see it, hit enter. I shall call it key input. Ideally, it would be some abstract input thing, but this is very specific to the keyboard, and so we'll call it key input. Maybe later, if we get around to adding Xbox controllers or something like that, then we'll abstract to another level. We'll add another level on top of this level, but at least this is a beginning. Let me grab both of these files, move them up here, hit Control-K-O to format my header guards, Alt-drag, underscore, Control-Alt. Well, I guess I could just go here. Let's get rid of these constructors like so. And then go back to key input. Throw this in a namespace. Like that. And Control-KF. I'm going to say class iKeyMapper. You've seen why I forward declare these classes in header files. iKeyMapper. Keymapper. And I also need int max value. What value am I talking about? I'm talking about the menu choice max value. So maybe I should say max action value like that. Bool. Initialize. Why boolean? Because as you've seen, I require all my systems to return a boolean indicating whether they initialized or not. This needs to be a pointer if I'm going to forward declare that. iKeyMapper. Mapper. Just say key mapper to be consistent with our field name here, and then int max action value. And then for reflexivity, we'll do a shutdown, even though I'm going to guess it will always return true. I'm going to copy both of those. I forgot to put input on this. Key input, Control V, Shift Tab, namespace, input, Control Enter. Control-KF, Alt-drag, key input, end key curlies, end key curlies, I think we're good, return true here, and also return true there. This key mapper gets key mapper, this max action value gets max action value. Now, there's no way that this could fail, these pointer assignments and stuff, but still, every initialize is just convention. Every initialize and shutdown returns a status code. I'm just defaulting to booleans. What I should do, though, is say if key mapper is equal to 0 or null or whatever you want, let's just stick with 0, then we could return false there, saying, hey, no dice, no dice. And you know what else? We could also say if max action value is less than 0. If it's negative, then there's definitely something wrong. But again, we're requiring the client of this to give us an enum with values that start at 1 and then go up by powers of 2. So we could go as far as checking for that consistency right here, but let's just get going. All right, look at me being lazy. Key input. Like all systems, it's going to need an update. We shall call update every single frame, and in that update, key input will figure out what actions need to be performed, and then anywhere in the game I can say, hey input, do I need to perform this action? Do I need to perform that action? So on and so forth. So let's go implement this update function right here. Whoops, didn't want that. Shift tab and grab all this. Control C, Control V, N key, curlies. Good. The job of update is to essentially roll through all these, figure out which ones need to be performed. I'm going to set up a new vertical tab group here. Push that over as far right as possible and zoom out a little bit. Just want that there on the right for reference. We need to calculate which actions need to happen in this frame. So let's go back to the header file and say int actions requested this frame. That's kind of a long variable name. How about just actions this frame? We'll stick with that. Go back to the update function, and at the beginning of the update function we will assume that no actions are being requested. We now need to iterate over all these actions, figure out what the key is for those actions, go see if that key is down, and then if the key is down, then we need to add that as one of the actions we need to perform. So int possible action, I'm doing control down arrow to scroll like that, gets 1. While possible action is not equal to max action value, then let's find out if the action is requested and so on and so forth. But before we do that, I am going to say possible action left shift equal 1. This is the update for my while loop. In fact, I could turn this into a for loop. This is the initial condition, this is the check, and this is the update. But I think the while loop is a little bit syntactically cleaner here. Let me describe, just in case you don't understand all my bitwise magic here, let me describe what's going on here. If you do understand it, feel free to jump ahead a few minutes in the video. But essentially what I'm doing is treating a 32-bit integer as an array of booleans. Remember, an int is 32 bits, and I can just use those bits individually to see if they're turned on or if they're turned off. So instead of drawing 32 bits, however, let me just draw 4. The same is true for 32. The same is true for 2 gabillion bits. It doesn't matter. Let's just do 4 because 4 is all I'm using over here anyway. So when I say int possible action gets 1, that puts a 1 here, and the rest of these bits will be a 0. And then I'll turn around to the key mapper and say, hey, what key maps to this action? Right now the action is accelerate. Okay, we'll do that logic right here in a second. But down here, that's the action I'm testing for. And eventually I turn around and say, okay, possible action left shift equals 1. That should be similar, or it is similar. Hopefully you've seen things like possible action maybe plus equals 1. You've seen the plus equals operator. It means, hey, do possible action gets possible action plus 1. Right? It does the addition and it does the assignment. All right, we're doing the exact same thing, but I'm doing that with the left shift operator here instead. Let me erase this out of our view. Let me rewrite this syntactically. I'm saying possible action gets possible action left shift 1. This is identical to what I'm doing up here. What does it mean to left shift by 1? That means take all the bits inside of here and push them over by 1. Push them to the left by 1. Now I could say 10, and that would move all the bits over by 10, but we only want to do this one at a time. And left shift, if you've ever heard of there's 10 bears on the bed and the little one said roll over, roll over. Maybe I'll keep my day job, but essentially it's saying, hey, everybody roll over, push 1, shift left to the 1. So this 1 here is going to die and take this guy's place. He's moving over to the left 1. There's no other 1s here, so everything remains a 0. Then this fills in with the 0. And we shall iterate again, but now our possible action is rotate left instead of accelerate. Okay, eventually we'll get down here and say left shift again, which means take this one, shift it to the left one. That'll put that one right there. And now our possible action is rotate right instead of rotate left. We'll go test and see if that's set up, and this fills in with a 0 in the meantime. And then we say, okay, well, left shift it again. So this one will move over to here, like so. This will fill in with a 0. And oh, look, this is the value of max value. It's an 8. This is a binary 8. I can write a binary 8 like so. And I say, hey, while possible action is not equal to the max value, well, it is equal to the max value, so we will not iterate again. We shall terminate the loop. I know that was kind of a fast way of describing what that does, but I think it's necessary. Let me get rid of this. And in here we want to say, what action are we on? What is the key for that action? Is that key pressed? If it is pressed, then we want to record that that action has been requested this frame. So int key gets key mapper. Do we have the include for key mapper? Nope. We forward declared it, but we didn't include it here. So pound include I key mapper. And I can say key mapper. Give me the key for the current possible action. Action. If get async key state. We've seen this function before in our really junky code. We need to pound include Windows for that though. Pound include Windows.h. And I want to pound define the, what is it, Win32 lean and mean again. But oh, we've already defined it in another file, and why don't we just define it project wise? So I think what I'll do is take that out, look for where we defined it before. Where did we define it before? Where's the search results? Find results. We defined it right here. I'm going to grab this, Control X, Control Shift L to delete the line, Control Alt L, and on the engine project, properties, in the debug build, preprocessor definitions, Control V, define that project wide. I probably want to do that in the release build as well, but you know, we'll come back to build configurations. That's actually important to have your build configurations working properly. Yeah, save that. Go back here. Get async key state. Give me the async key state of key. You'll notice get async key state returns a short. There's 2 bits in that short. One of those bits indicates whether the key is currently down. Another bit indicates whether the key has been pressed since the last time that we called the get async key state. But since we're polling this thing at 30 to 60 times a second, it's not going to make that big a difference. That's why the function's called get async key state, meaning give me the asynchronous key state, meaning asynchronously somebody else might have pressed the key down. Tell me if they pressed it down between now and the last time I asked you. Not really important. All right, for now I just want to say, hey, treat that short like a Boolean, convert it to a Boolean for me. That means if any of the bits in there are turned on, the result will be true, and that means that the actions, this frame needs to include, this is an OR equal, the possible action. All right, this is the same as saying actions, this frame gets actions, this frame, or possible actions. Again, I highly encourage you to go watch my bitwise operations videos, but it's the same idea here. If I have my actions this frame, let's say this variable is these 4 bits, and we initialize them all to 0. That's what we're doing right here, is initializing them all to 0. And then the possible action, I already showed you how that one starts out with a 1 down at the far right here, and we shift it left as we go along in our loop. Well, let's just say that the accelerate key is down, and this returns true, saying yes, the accelerate key is down. Then what we want to do in this actions this frame is say, hey, there's an accelerate this frame, turn that on. Well, the way we do that is by ORing. Here's the OR. We're ORing this value with what was previously there. Remember, I had a 0 here, and if I take 1, which is true, and OR that with 0, which is false, well, false or true is a true. So that will we'll turn that to a true because we do the assignment as well. And then false or false is still false. False or false is still false. False or false is still false. So that's why I'm doing that or equals thing there. All right? Tell me the key. Is the key down? If it is down, then that's the actions for this frame. And then there's two other helper functions that key input needs, and I think we shall be done with it. Let's go here and add hot actions. Okay, I was tempted to say actions this frame, but I don't. You know what? I do want to say actions this frame, but this function name conflicts directly with this variable name. So rarely do I do this. I've seen a lot of programmers do this, and I can't disagree. But we'll just prefix it with an underscore, even though that's so not consistent with my coding style. Whatever, underscore, and then actions this frame. This will be a const function, so we can ask directly, hey, what are the actions requested this frame? Or I can say boolean action hot this frame, and int action. Actually, let's say actions hot this frame because we can take in multiple actions. Not necessarily all the actions. This would certainly work for all the actions, but we'll just say actions there. This will be const as well. And grab both of these, copy them, go back to key input here, paste, shift tab, delete, grab this, control C, control V, control V. This video is getting long, isn't it? Sorry this video is too long. It's probably exhausting for you. It's definitely exhausting for me. Return the actions this frame. Return actions this frame. In fact, this should really be an inline function. It should be an inline function. Why not? Let's do it. Actions this frame. Return actions this frame. Generally, I like to put these in INL files, but it's short and sweet. Maybe I can get away with that. And then actions hot this frame. Let's get rid of this. But essentially, this function, I'm saying, hey, are these actions hot this frame? Are all of them hot this frame? And again, that's just more bitwise logic. Return actions this frame and actions, and that should be good enough. So I'm actually a little oh, this needs to be an underscore. Look at that underscore messing me up. Oh, that's a function pointer. Yeah, so bad. Let's say actions this frame. Let's say the actions for this frame are this, and they pass in right here. So this actions this frame is that. This actions, what they'll pass in, let's say they pass in a 0, 1, 1, 0. What's going to pop out? Well, if I AND it, 0 and 0 is 0, 1 and 0 is 1, 0 and 1 is 0, 1 and 0 is 1 and 0 is 0. So that'll still be true. So actions hot this frame will return true if one of the actions is hot this frame. You know, I'm really just trying to make this an orthogonal feature by putting an S on here, allowing us to test more than one action at a time, but I'm actually going to take that off as a hint to the consumer just to test one action at a time. And generally, I'm only testing one action at a time anyway, and I'll come back and patch that up if necessary. Listen to me saying I'm going to come back and patch this up and come back. Generally, you just don't come back and patch it up. Oh, it's probably because the video is getting so long. I just want to be done with this, but I think that's the general idea. In the next video, I'm going to try building this. We're going to wire it into our game. As much as I've kind of thrown this together real fast, it is actually a nice design pattern that works well, because when we make a new game, all we have to do in the new game to test for input is to write a new key mapper. All right, and here Here's the key mapper we did in the last video. I just have to write one of these again. Just say, hey, these actions and these keys to go together. If I want to change that up, I can certainly change it here. It is my central single point of truth, which is nice. We don't like saying things twice in programming because that's always a headache. You've seen me refactor and factor and factor as much as possible. Same idea true here. And then I also don't have to worry about rewriting the logic for key input. I mean, we haven't really tested this to see if it works yet. But if it does work, then this is written once. I can reuse it over and over again. And it's good for several games into the future, which goes back to a nice thing that a grumpy old man taught me one time at one of my jobs is it's good when you can have old code call new code without having to change the old code. And what he meant is this will eventually become old code, but it's still good code. And as I write new mappers, new key mappers, then the old code can call the new code without having to change the old code, and we'll still get our input working the way we like. So, I need a drink of water.